What's good, YouTube? It's your boy. I'm here to teach you some maths. Now, what I noticed is on YouTube, there's plenty of maths tutorials. They're all very dry and very boring. The goal here is we're going to learn maths. We're going to hopefully have a little bit of fun on the journey. It's going to be a bit more YouTubery and a little bit less teachery. Okay, so we're going to jump in. I'm going to jump in and go ahead and I'm going to hit every single exercise in the textbook. What I recommend is, as you're learning the maths, if you're going through the textbook, why not have a go at the exercise first, see where you get to, and you can jump in with these videos if there's anything you're stuck on, or if you want to check you're working against mine so that you can grow as a mathematician. So my plan is hit all the exercises in the book, maybe go pure 1, pure 2, applied 1, applied 2, maybe hit some further as well. We'll see where we get to, but let's jump in with maths. Okay, so here we have some index laws. We're going to be looking at index laws. How do we manipulate these things? What are the rules? Okay, when I have x cubed multiplied by, I've got my little multiply sign small there because it can get a bit confusing with x's and multiplieds in the same universe. So this I'm calling multiplied by, that's my little cross symbol. What we're going to do is we're actually going to add up the powers, okay? So if we remember cubed, what this really means is x times x times x, and x to the 4 just means x times x times x times x, okay? All of these have little x to the power 1s on them, you know, and when we're multiplying things, we just add the powers. So x cubed times by x4 is going to be x to the power 7, okay? That 7 is x3 plus 4, okay? Right. Let's have a think about this one. Using the skills that we've just learned, how are we going to tackle this? Okay, have a think. All right, so there's only one other layer of complication, and that's these coefficients in front of my variables. What I'm going to do, okay, is in a multiply, I can move any of the terms around however I want. 2 times 3 is the same as 3 times 2, so I can move this one around. So I can say this is 2 times by 3 times by x cubed times by x squared, okay? That's the same thing. And now look at this, we can apply our skills that we learned in the previous one, okay? So x cubed times x squared, okay, that's still going to be 2 times 3, but that's going to become x5. Boom, okay, 2 times 3, 6. Quick maths, 6x5. All right, let's keep going. When we divide some powers, okay, we're doing the opposite, okay? Effectively, we're going to take a... we're going to look, okay, at why this rule applies. So the actual answer is going to be k to the power 1. That 1 is coming from k3 minus 2. So it's k to the power 1. We took the 2 away from the 3. But why is this the case? Well, let's rewrite this. Let's call this k times k times k, and we'll call this k times k, okay? What we can spot here, okay, is that we have a common factor appearing on the numerator and the denominator. Let's actually isolate that. So on the numerator, we have k times k times k, and on the denominator, we have k times k. Now, anything divided by itself is 1. 10 divided by 10 is 1. How many times does 10 fit into 10? It fits once. 2 divided by 2 is 1. How many times does 2 fit into 2? It fits once. Okay, so this, pa-pow, okay, k times k over k times k just gives us that 1. Okay, so that'll be 1 times k is our answer. Okay, so we see why this is working. Let's have a look at this one. Last sort of thing we can encounter with index rules. Okay. Now, y squared to the power of 5. This is another way of saying y squared multiplied by y squared multiplied by y squared multiplied by y squared, 1, 2, 3, 4, multiplied by y squared. Now we use the rule that we've already used, okay, and we've looked at this. Okay, x cubed times x squared, that was x to the 5. Let's have a little think about what's gonna be occurring here. Well, I have y squared times y squared times y squared times y squared times y squared. Okay, that's gonna give me, if I added up those numbers, gonna give me y to the power of 10. Now there's an easier way to do this, okay? All we're gonna do instead, okay, is we're going to look and say, instead, we're going to do y to the power of these two numbers multiplied together. So that's y to the power 2 times 5, which gives us 10. So I can think of this as y to the power of 2 times 5, which is y to the power of 10, or I can think about it this way, which is y to the power of 2 plus 2 plus 2 plus 2 plus 2, okay? We see why this works. Let's look at this one. Okay, now we're having fun because we're combining these rules together. Let's look in this first case. In this first case, I have p cubed squared. What I'm going to do is I'm going to go ahead and multiply the powers. That's going to be p6 divided by p4. Now the second rule I know is, of course, I can rewrite this way, p6 over p4. That's a lot more clear. Okay, well, not really. My denominator's a bit all over the place there. P to the power of 4. Okay, we can take out that common factor, which is on the numerator and the denominator. We're going to take away the powers from each other. So I'm going to do 6 minus 4, which is going to give me p squared. Okay, so we use one rule first here, and then we use the second rule here. So we're now combining these things. Have a look at this one. Okay, this one seems more complicated, but it isn't really if you write it out properly. Okay, so we've got a few steps. Think about how we'd get stuck in with this. Okay, have you thought? Yes, good. Thinking is important. Now, when something is squared, we're multiplying that bracket by itself to the number of times given, right? So another way of thinking about this is 2a cubed multiplied by 2a cubed, okay? Now, again, multiplication can happen in any order I like, okay? So I'm just going to put my terms in different places, and suddenly this will start making a lot more sense. So if I go 2 times a cubed times a cubed, ooh, this particular thing starts looking a lot more simple, right? So we're using our old rules. So a cubed times a cubed, that's going to give us a6, and this is going to be 4a6. Okay, so another way that you could have thought about that was just going 2 to the power 2 multiplied by a cubed to the power 2, and that would have got us to the same place without writing everything out. So 2 squared is 4, a cubed squared is 3 times 2, a to the power 6. Okay, so we're splitting things up a little bit. We're looking at the coefficient, we're looking at the variable, we're applying the power to both of them. Okay, now we're dividing through, so this is just the first step. We've just looked at this term, but it's this term divided by 2a cubed. So we're just going to do that. 4a6 over 2a cubed. Okay, I see some common factors emerging. So if, let's go with another colour. So if I say 2a cubed, okay, like this, over 2a cubed, this will be 2a cubed here. Funnily enough, we could have skipped the whole step there. That would have been much easier. I've rewritten the numerator like this, okay? I've brought out this factor of 2a cubed, and 2a cubed divided by 2a cubed is 1, so these get deleted and yeeted. That leaves us with 2a cubed, okay? I could have thought about it looking at the coefficient and the constant separately, so I could have said, okay, a to the 6 minus 3, that will leave me a to the 3. I could have then said 4 divided by 2 is 2, okay, but a nice formal way of looking at it is that bringing out of that common factor, okay? Right, we're in the next section. So we finished section 1. Now we are in section 2. This is where it gets extremely fun. We've got to expand some brackets. Expanding brackets is my favourite thing. I have a method called the firework method, which if these videos go anywhere and you stick with me on this journey, we're going to use the firework method all the time. You draw a very beautiful firework. There you go, and you've got to do the sound effects as well. See how that looks a little bit like a firework being fired up and coming back down? And what we're going to do is we're going to follow the lines of that firework, and we're going to multiply everything that touches together, okay? So minus 3y is going to be multiplied by 4, so that's going to give us minus 12y. Minus 3y is going to be multiplying minus 3y, so that's going to be giving us plus 9y squared, okay? There's not really much more you can do to simplify that. I mean, it's an expression, it's not an equation, so we're not looking to solve it or anything. So there you go, firework method. And we're going to do some more of that. Okay, here we go. Have a think about how you'd solve this one. Wrong, okay? You just got tricked. Let's not forget what is hidden here. 5x minus 6 minus, what's hidden? There's a 1 there. Minus 1 times this bracket, 3x minus 2. When you've got just a negative, okay, there's a 1 hiding there that we sometimes leave off because it's easier to write shorthand. But that 1 exists, okay? So the step that we have to do is guess. Guess what we have to do? Correct. Firework method. Okay, so we've got a firework method, this stuff right here. Okay, so that gives us 5x minus 6 minus 3x. Oh, you didn't like that, did you? Plus 2. Okay, so this expression becomes 2x minus 4. Boom. There we are. Be careful with that. Okay, I think last but not least, okay, I think this is the last one from that exercise. Exactly the same thing, but with, it looks a bit more messy. So why don't you have a go at this? And we're back. Let's see if you agree with me. Bam, bam, lovely firework. Bam, bam. Okay, so that's going to be 6x cubed, adding the powers. There's a hidden x to the power 1 there. Okay, so we're going to add those up. Plus 3x squared minus 15x cubed plus 20x squared. That's a squared. Alrighty, so now we've just got to collect the old like terms. So we've got 2 cube terms there, so that's going to be minus 9x cubed. That makes sense, doesn't it? Yes. So then that's gone. And then these two, 3 plus 20 is going to be plus 23x squared. But I'm ticking it out of hubris and sanguine attitude to maths. I haven't checked these answers. Last but not least, the last section of section 1A, your first ever A-level maths section. Aren't you proud of yourselves? Well done. Thank you for being here and choosing maths. It's a great subject. It gets better than just index laws, I promise. Stick with it. Don't drop out first term. Here we go. Or if you're going to drop out in the next couple of weeks. Don't drag it on till Christmas. No. That's where the hard times happen, okay? So, here is a fraction. How can we apply the skills that we already know? Well, we're going to go ahead and rewrite this fraction, okay? So, it's 6x to the power 4 plus 10x to the power 6 divided by 2x. That is the same as 6x4 over 2x plus 10x6 over 2x. Okie dokie? Love it. Alright, so I need some more room for that. Here we go. Now what we're going to do is we're going to crank the handle, okay? If I wanted to do it the sort of more official way, I would say 2x over 2x, and that would leave me 3x cubed. Cancels, and that gives me 3x cubed. You can do it visually without actually looking for that common factor by just saying, okay, x to the 4 minus 1 gives me 3, 6 divided by 2 gives me 3. You don't necessarily have to write it out every time. So we're just going to do that shorthand method on the second one. So 6 minus 1 is x to the 5, 10 divided by 2 is 5, okay? Happy days. Last couple, the end of the first ever Learn Things, Have Fun video. Let's bring it home strong. So we're going to have a go first. Here you are. And we're back. So we're going to split this up. 8x cubed plus 5x. Oops, sorry. I'm going to rewrite that over 2x. Over 2x. Let's see how we can simplify this one over here. So we can say that is going to be 4x squared plus 5 divided by 2. Can't really do a lot of that. So we're just going to leave that as 5 over 2. You could also go 4x squared plus 2.5 if it's a final answer. If this is part of an intermediate step, I would leave it as a fraction because you won't lose accuracy as you continue with the problem. Last but not least, have a go. Welcome back. let's split this thing up. So I've got 9x 5 over 3x minus 5x cubed over 3x. Okay, so 5 minus 1, that's going to give me x to the 4. 9 divided by 3 is 3. Minus 3 minus 1 is 2. Oops, sorry, hang on. X to the power 2. 5 over 3. Yep, nothing there. So 5 over 3. That's fine. You can just leave it as a little fractionarino there. Okay, so I'm just trying these things out, seeing if there's an audience for maths with a more fun kind of vibe. Let me know what you think, and we'll see where these videos go. Maybe this is the first and last, but maybe, who knows, this could be the start of something beautiful. Maybe we do loads of past paper questions and we get all the textbooks, and maybe this helps somebody. So, yes, thank you very much. Peace and love. Smash that like button, you know it, and I'll see you next time.